So permutations when all objects are not distinct. Number of permutations of n distinct objects taken all at a time in which p objects are alike and rest are all different is n factorial upon p factorial. Now, let us see the explanation. Let us assume that there are x permutations are possible. So I am assuming that let x permutations are possible. Now if I consider one permutation, so among all x permutations, I am considering one permutation. In that one permutation, you will be having total n objects only. But in this, somewhere, anywhere, that is somewhere it will be p objects. P objects are all same because p objects are alike. So p objects are alike will be there. That means remaining n minus p are different. Now let us replace this p objects which are all same with p different objects. So I am replacing all the like objects with p different objects other than this n minus p also. That means now all will be what? Distinct objects only. And because all are distinct and these p objects only I am replaced, so these p objects can be arranged among themselves in p factorial ways. The p objects among themselves can be arranged in p factorial ways. Why? Because there will be p blanks which are all same that we have replaced with the new objects. So the among themselves can be arranged in p factorial ways. Now for one permutation, I am getting p factorial ways of arrangement. Now for x permutations, it will be x into p factorial. Now which is same as arrangement of all n objects with different. Why? Because always we are replacing different objects. That means this will be same as number of permutations of n different objects taken all at a time, which is same as n factorial. Hence x equal to n factorial upon p factorial. That means whenever you are having n objects, in that p objects are alike. So whatever the number which are same, that will come in the denominator as a factorial. So total objects factorial upon how many are repeated, that will come in the denominator. But here only p objects are alike and this can have extension also. So number of permutations of n objects taken all at a time in which p objects are alike of first kind, q objects are alike of second kind, r objects are alike of third kind, and rest are all different is n factorial upon p factorial, q factorial, r factorial. That means here we are arranging all only at a time, but there are some repetitions. That means p objects are same and q objects are also same, different from p objects, and r objects are also same, different from the p objects and q objects, and also few more are there, they are all different is n factorial upon p factorial, q factorial, r factorial. Now let us write one example. Consider the word banana. Number of words that can be formed, using letters of the word banana. Number of words that can be formed using, let us say, all. number of words that can be formed using all letters of the word banana
Done, sir.
with or without meaning. So with or without meaning.
With meaning, no word is possible.
With or without meaning is. Now you can apply the previous concept. So total number of letters
6.
6. That means 6 factorial upon. In this you check the
2
repetition.
factorial and
Anything
3 factorial.
A is repeated 3 times. That means 3 factorial. And n is repeated 2 times, 2 factorial. And remaining is 1, that is 1 factorial. So number of permutations of n distinctive objects arranging in a row in which m objects occur together is n minus m plus 1 factorial into m factorial. The m object which we want all together, always you consider as a single object. Then the total number of objects will be n minus m plus 1, because we are eliminating m objects and we are adding this as a single object. So that's why n minus m plus 1 object. Now this n minus m plus 1 object can be arranged in a row as n minus m plus 1 factorial. Now for each arrangement of this, there are m objects which are together. So all the m objects can be arranged among themselves in m factorial ways. So these two are in a succession. That means n minus m plus 1 factorial into m factorial. Number of permutations of n distinctive objects arranging in a row in which m objects never occur together.
Sir,
So number of permutations of n distinctive objects arranging in a row in which m objects never occur together means from the total number of arrangements you subtract where the m objects occur together. That means from the previous one you have to subtract. So n factorial minus n minus m plus 1 factorial into m factorial. Number of permutations of n different objects of first kind and m different objects of second kind in a row, so that all objects of second kind come together is n plus 1 factorial into m factorial. Why? Because m objects of second kind we want to have together. So this m different objects can be considered as a single object. Then the total number of objects will be n plus 1. So arrangement will be n plus 1 factorial. And the objects which are together among themselves can be arranged in n factorial. So n plus 1 factorial into m factorial. So number of ways of arranging n different objects of one kind and n minus 1 different objects of another kind, such that no two objects of the same kind come together is. So this problem you can interpret as like 5 boys and 4 girls sit in a row such that no 2 boys nor no 2 girls should be together. That means first if I arrange 4 girls in 4 factorial ways, then in between the girls 3 positions will be there and in the extreme 2 positions. That means these 5 places can be occupied by 5 boys that can be arranged in 5 factorial ways. So the total number of arrangements will be 4 factorial into 5 factorial. That means in this case first you have to arrange n minus 1 distinct objects in between n minus 2 places and extreme 2 positions. So n minus 2 plus 2 becomes what? N. So that n blanks will be allotted for n different objects. So n minus 1 factorial into n factorial. Number of ways of arranging n different objects of one kind and another n different objects of second kind, such that they are in alternate positions. So here also you can consider one kind of objects are boys and another kind of objects are girls, but the number of boys and girls are same, but they should be in alternate position. So what's the answer?
Sir, 2n factorial whole square. 2 is
2
outside
is
the square.
2 into n factorial into n factorial, or you
Yes,
can
sir.
say 2 into n factorial whole square. Correct. Now, why it is 2 into is starting with a boy or starting with a girl. So
Yes.
n factor into n factorial into 2. That is, if I consider the first one as boy, second one as girl. So in alternate position. That's why starting with a boy or starting with a girl. That's why it is 2 into n factorial into n factorial.